welcome to the session. I'll just get it done all over again anyways. So yeah, um, welcome to the session, guys, everyone who have just joined in. My name is Asutosh, and I am a developer evangelist at R3. So in this session, we're going to learn about Corda. It's a beginners session. So the question someone had is this a webinar for beginners? Well, yes, this is the webinar for beginners. For everyone who are new, we are just going to cover Corda from the very high level. So welcome to this session today. So before we start, we have Arena here, who is there, who will be helping you guys with any questions that you have on the chat. And obviously, I'll also be looking at it from time to time. But yes, he's over there for you guys always to take care of all your questions. So anything that you feel like you want more information or something, just feel free to drop a question over there on the chat window, and we'll take it up from there. And yeah, so let's get started. And before that, let's look at some of the resources since this is a beginner session. So I'll just go through some of the resources which will help beginners or someone who is new to Corda. The first and the most important thing I would recommend is to join the Corda Ledger Slack, which is available, or just go to slack.corda.net, put in your email ID, and then you're ready to just join in. You'll get an email, and then you can just join in. So it's a session of or it's a community of over around or close to around 9,000 developers now. So just go there, have fun, talk to fellow Corda developers, your experiences or whatever. And then documentation obviously is a great resource for developers. So you're new to Corda, you want to know anything about Corda, it's available in the documentation. So docs.corda.net is the documentation. We also have a free training site. So if you like the training kind of a setup, so go over there to training.corda.net and learn it for yourself. And the GitHub repo, obviously, Corda is open source. So you could also go and check out the code for the platform as such. You want to contact us or the DevRel team in general. So you could email us at devrel@r3.com. You're a Twitter guy, so feel free to tweet. The handles are @Corda blockchain and @inside R3. Feel free to use the tags #Corda and #R3. All right, so once this is behind us, let's get going with our session. Well, so first of all, let's look at what do we believe. So since we are working on distributed ledger technology, which is like something of sort of a new technology, so we must have some sort of a belief. We need to have a belief in ourselves and believe in the technology. Um, so so let's look at what we believe in and what we see in the future. So we believe that the distributed ledger technology is here to stay, and it's not something like a hype which was there, and it's not something which will go away, or it's not that we believe that blockchain is a hype and it will go away. So we believe that it is here to stay. There are a lot of different production applications also which are going into production with blockchain. So there is no reason to not believe in blockchain, since it has a lot of these features, like it reduces cost, reduces the go-to market time, increases your efficiencies. And also, why would something that has so much of value would be going out of going out of people's belief, right? So let's just believe in it. And since you guys are joining us here, I believe that you guys do also believe in Corda or in blockchain in general. So with that, let's move on. So let's look at Corda, since it's a very beginner session. So you guys are quite new to Corda, so just let's have a look at how basically the entire thing came into picture, how the entire thing did shape up, how Corda came into existence, right? So it was back in September of 2014. Well, it's a little bit of a history here, but don't worry about it. We're not going to take a lot of time to understand this. We'll just go through this very fast. So it was September of 2014 when blockchain was at its peak, and everybody wanted to do something on blockchain, right? So there were a few banks who had a meeting sort of, and then they decided they're looking at different blockchains and how they could utilize blockchain in the financial sector. And David Trotter, who's the CEO, was there in that meeting, and they looked at different blockchains and came to know that, well, none of them actually suit the requirement of business, all the blockchains that were there at that point of time. So 1 year down the line, all these banks, along with one more, you can see the logos there, they came together, and they decided to build a blockchain or a DLT system, which is more of enterprise grade and is suited for global financial markets. And then those 9 banks, they formed a consortium and started working towards that. And 3 months after that, in December, it just grew to something like 42 banks. And then we never looked back from there. Actually, close to a year down the line, we basically had our very first version of the open source Corda, which was released in November of 2016. And and then obviously we were also working on the enterprise part of things. So the first version of enterprise Corda was released in July of 2018, and that's where it was version 3.0 to keep it in sync with Corda open source 3.0, which was also released during the same timelines. And fast forward today, that ecosystem, which started with 8 or 9 banks, has grown up to over 200, or uh, in August it was over 200. But if you look at now, August of 2018, it was over 200. If you look at now, it's about over 350 different participants, not just finance, but all different all different industries have joined in. So we are not anymore looking at just finance, but it's more like we're looking at a whole range of different use cases in different industries. So Corda is not anymore a finance blockchain, but it's more of a DLT which can serve any different kind of use cases, basically in multiple different domains. Right. So just to have a look at the different participants of the ecosystem, which we talked about, 350 plus participants. They're broadly categorized into different categories, but I'll not talk about that. But this is just, you could see some of the big names over here, which is what I wanted to point out. All right, so let's just move in and try and understand why it was that we chose to develop Corda. Why not build something on the traditional blockchain which was already there? So if you look at traditional blockchains, there were few peculiar problems which was not fit for business. These are the most prominent four which I'm showing you. They didn't had a strong identity, which means if you look at any of these public blockchains, right, then well, the problem is with identity. All you know about your counterparty there is that you know them by a pseudo-anonymous key, which is basically your public key, right? And that's what you know about your counterparty. You interact with them using that key, but you don't really know whether they really exist, right? Um, so how do you do transaction with someone? All about him you know about is a key, right? You don't really know even if it exists or not. So that's a problem. You can't do business in such kind of circumstances, right? So next problem is around privacy. Public blockchains are great. They do have a thing called transparency, right? So which is sort of good in a lot of use cases, but if you think of it in business terms, right, um, how would you do business with someone who is how would you do business in a situation basically where whatever you put in a blockchain is it just gets distributed to everyone, right? You have sensitive information which you cannot share, right? Something like pricing information or maybe some patent data or something. How would you share? Um, how do you just share all those information in the blockchain and everybody know about it? Well, that's not a good thing to be, right? So the problem of privacy is there. So Corda solves that. We'll see how that happens. And then the next one is around finality, which is the problem that I talk about here is you need to know a little bit of um, traditional blockchains to be able to understand this problem. If you have done any transaction on something like a Bitcoin or Ethereum, you might have come to this situation that you do a transaction and your transaction is supposed to be completed within an hour. But that's not always the case. Sometimes you get it in less than an hour. Sometimes it even takes days. So there is no finality as such, right? It's probable. You don't really know when that finality is actually going to occur. Well, that's because of this concept of blockchain where you need to have a single true blockchain. You can't have branches in your blockchain, right? But there are cases where something like, for example, in cases where perhaps someone is trying to create forged blocks, or for some reason two blocks got created on the same time. In that kind of cases, what happens is you just have a something like a branch in your blockchain. So that creates a problem because you don't know which branch would actually become the true blockchain, and the other branch would get rejected after some time. The one which grows faster will become the true blockchain. And what happens to the transactions which are in the other branch which was supposed to be rejected in some time? And if your transaction happened to be in that block, then your transaction is again going to be mined and then put in another block and then again appended onto the main blockchain, which is where the problem of probabilistic finality comes in. The finality is not instantaneous or not certain, I would say, but it's probable. So that's a problem which Corda tries to solve. And then the ease of use. You learn about public blockchains, then one is that you have to learn about blockchain as a concept, and then the other point is you have to basically go and learn certain new sort of all these different tools and all these different not exactly tools, but I would say languages and protocols which they really create, which is very much specific and fit for a particular blockchain platform. Now that's give you a steep learning curve, right? Why not use something which is already there? So Corda also tries to solve that, try to make lives of developers easier. Um, all right, so let's move on and try and understand how we solved all these different problems. Uh, so, so first problem that we were talking of is the problem of identity, right? So Corda has um, Corda is not a public blockchain, so which means, well, we have a question which says, will there be coding in this session? Well, this is not a coding-based session. This is just a sort of 101, which is like just the Corda intro part. We are not doing coding in this. That is something which we do in the boot camps, which will happen sometime later on, probably this month or next month. We will let you know, and we will have an announcement around that. But this is not a hands-on session, no coding for this one. Um, well, yeah. So let's move on with our slides then. Okay, so the problem of identity. So how did we solve identity? Well, there wasn't, Corda isn't like a public blockchain, so you can't just join in. You can't just download Corda and join a network, right? You have to be given permission by a certain entity who will permission you into a particular Corda network. So which means during that process, you have to go through a process where you have to give your legal identity, which is, if you look at the slides here, there are three different identities here. One is Titan Technology, the other is Paytranscorp, and then we have Acme International, right? So what are these? These are real identities. These are the legal names which these different identities would be identified by, other than the public key, which is obviously they have a key pair which they use to sign the transactions. But then it's not just these keys, they have real strong identities, which so it becomes easier for people to communicate with them because they know that these guys really exist in a network. They are real identities. Well, moving on, the next thing is communication between, so this is where we were talking about the privacy. Not everything in Corda is known to everyone. So communication between nodes is point to point, which means once you basically do a transaction with your counterpart, then the information about that transaction is only available with you and your counterpart. So in this example that I'm showing you, if you look at, we have Titan Tech, we have Baytranscorp, and we have Acme International, and there is a transaction happening between Titan and Baytranscorp. So when this transaction is completed, then the information about this transaction is only available with Titan and Baytranscorp. And as you can see, Acme International, who is there in the network, but he has no information in his vault. Now, vault is generally the database which your node have, where, or the ledger, you could say. And now that's what is the point-to-point communication and the entire privacy model of Corda. You don't really distribute all the information with everyone who is in the network, but you just do it with people who should know about it. But Corda as a platform, since it's a DLT, it will make sure that if there are n number of parties who know about a particular asset, which is the vehicle here, then these different parties would see the exact same version of the vehicle. So that's how the privacy model of Corda works. All right. Now we see a separate different component as well, which is right at the bottom, which says notary pool, right? What exactly is the notary pool and why do we really need it? Now, notary pool is the thing which does the consensus. Well, if you look at other blockchains, the consensus is done at a global network level. Everyone is involved in the consensus. But here, if you look at it, well, the transaction is point to point, so others don't know about it. So we need a particular component in the network which will help us prevent something like a double spend. What's a double spend? If now taking this example, if Titan has already sold the vehicle to Bay Transcorp, how would Acme come to know that this vehicle has already been sold? And when Titan tries to sell this to Acme again, how would Acme come to know that this has been sold? He would very well accept the vehicle because he never knew that it was sold, right? Because of the entire privacy thing. So we have this notary pool, which is not a single node, but a pool of nodes who would sit together and come to a conclusion whether a particular transaction is a case of double spend. So all transaction has to go through the notary. There might be multiple notary pools, not just don't just have to select a single notary pool. So depending on your network topology and stuff, you could have different notary pools, and then you could choose which notary pool to use. But then the transaction has to go through one of the notary pool, and the notary pool will just give will just say that whether this is whether this transaction is a case of double spend or not. But when I say that the transaction has to go through the notary pool, this doesn't mean then the notary really looks at what is there in the transaction. The notary doesn't know whether there is a vehicle being transacted, or there is some cash being transacted, there a cat being transacted, or whatever has been transacted. Big notary just knows that there is a transaction, and he'll just look at the structure of the transaction, not the data of the transaction, and he will identify whether there's a case of double spend. Now, all of this happens looking by the UTXO model, which Corda basically uses, but we'll not go into the technical details of that. We will learn more about it in something like a boot camp. So feel free to join that if you want to learn more about that. But yeah, for this thing, the notary pool is the point through which all the transaction goes, and the notary pool is not something which sees everything. It just looks at the transaction at a very high level, or just the structure of the transaction to identify whether this is a case of double spend. Now, why are we talking about this? This is because we want to take care of the third scenario which we talked about, the finality here, right? So notary pool once has given a go ahead to a transaction. Once the notary has said that there is not a case of double spend and this transaction could go ahead, then there is no way that this transaction can be reverted. So it's not like we have this blockchain and then the blockchain has branched. So there is no blockchain as such, but there is a chain of transactions, obviously. Um, and once a notary has said that a transaction is complete, it is complete. There is no way you can roll back the transaction again, right? So that's finality, true finality, not something like probabilistic finality which exists in other traditional blockchains. It's true real finality. All right, the final point, last but not the least, obviously, is the ease of use, right? So we mentioned that you have to learn different protocols and sort of languages if you want to develop on other blockchains, or other public blockchains for that matter. But with Corda, we have tried to make sure that developers feel it easy to use. So we have given stress to something which is already there in the market. So if you look at all these technologies that we use, Java, DBMS, ActiveMQ. These are relatively used in almost all, or at least majority of all the enterprise softwares which are developed, right? Which are available around the world. So Java being there, and Java, DBMS, and all these things are like they have been there in the market for years, and it has gone through the test of time. It has been tried, proven, and so you would also get a lot of resources around that. You have to run around to find resources um, which know a particular technology which was just recently invented. So Java developers are abundantly available. Almost all the developers know Java, and everyone who knows Java also supposed to know DBMS. These are the two technologies which is used everywhere, right? ActiveMQ is again simple message queue and message broker, which is again a very well-known technology. So we don't reinvent the wheel. We don't try to invent something new. We have used just what is available there. So it's easy for you guys to learn as well as integrate with your existing systems because they would use the same technologies. Right. So there you go. We have solved all of our problems. The identity, privacy, finality, ease of use. So it's all solved all the four problems which we talked about in traditional blockchains. have been overcome by Corda. And that's why we say that Corda is the third gen blockchain platform, which is more or less suitable for businesses. All right. Looking at how we learned about Corda, but Corda as such doesn't work in alone, right? You have to have a network to be able to work on this kind of. It's a DLT. You have to have multiple participants. There has to be a Corda network, right? Now, a Corda network is not something like a public blockchain where you could just download Corda and join in, right? So we talked about identity, which will basically allow you to join a network. So that identity is called as the doorman or the identity manager, who holds the root key authority. And every time a node wants to join this network, he has to be given permission by the identity manager or the domain. So how that happens is he will sign his certificates, and once those certificates are signed by the root authority to the domain, they can be allowed to join the network. And in that process, there is something happens which is called updating the network map. Now, there are multiple identities within the Corda network, but how do they know each other? Where do they search for each other? So that place is called as the network map. So it's like a directory where you could just check for who are the different identities who are available in my network. So every time a party has to join a network or a node has to join the network map needs to be updated so that others know that this new guy has joined the network. Now there could be notary operators as well, just like we said, notary is a component of your network. So your Corda network would consist of certain notaries and then certain other Corda nodes, which could be an open source as well as enterprise, right? So Corda comes in two flavors. If you guys want to don't know about this, well, open source is the community version of it. It's open source. There is also an enterprise version, which is more for production use cases. You want to have higher throughput, you want to have better HADR capabilities and other kind of non-functional requirements, which is required for mission critical applications and stuff. So Corda Enterprise is your way to go through, is your way to go. And basically it's a paid product, which is a commercial offering from R3. And so Corda as well is a platform. Right now there is so you developers wouldn't develop Corda, but you would write applications on top of Corda. We call those applications as Corda apps. It's a short form for Corda decentralized applications. Well, these are the distributed applications which run on Corda nodes. Might have heard of the term smart contract, right? So that's analogous to Corda app in the Corda world. So apps are generally just binary files, which are your jar files, which once installed on your nodes, on your different Corda nodes, then two people having the same app can basically, it's more like they have installed a particular application on their nodes, and then they can start to communicate with each other and do transactions and share facts and do their business workflows, right? So that's what a Cord app is. It's that application which people develop or developers like you guys develop and installed on your Corda nodes. Let's look at how a Cord app would look like, how it is actually structured. So Cord app generally has three different components: a state, a contract, and a flow. Now, if you look at this, what is a state? Well, state is your representation of your facts, right? If representation of your rather asset and the facts in the asset. So we talked about a transaction about a vehicle, right? So the vehicle would have certain facts, and what are those things? Like buyer, seller, and then you could have something like what's the model of the vehicle, what's the make of the vehicle, and all these kind of things. So all these are different facts which needs to go inside a particular object. So that would be your state object, and then that's the first component. So the first component is your asset, which is represented by the state object. Then we have contracts. Now, what exactly are contracts? Well, contracts are something so you have the state, but this state as such needs to evolve. So whenever there is a sale of this state, the buyer and seller or the owner of the state would change, right? When Titan is owning this vehicle, there would be owner field which would say owner equals to Titan automobile. right? And then when he sold it to someone like an Acme International, then that owner field will change and it becomes Acme International, which represents that Acme is the current owner of your vehicle. Now this change, there has to be certain, so this is like a transaction which you do, right? And this transaction involves changing the state, and there has to be certain process around that, certain business rules around that. So something like, say, whether this vehicle is legit, whether it has something, some other, whether it, when you do a transaction, whether the vehicle is basically like, is that the right vehicle which I'm getting or something. You have to do all those kind of validations and checks when you execute this transaction. So all these validations, business validations, are put inside a contract, and that is what becomes the contract of your of every state. So every state will be tagged with a contract. So as and when these states evolve, you have to check whether these contract rules are validated or not. So every time your contract rules are not validated, we don't accept that as a valid transaction. Right? So we have states, which are your assets, and then we have contracts, which are the business rules which govern that change of that state. Right? And next, we have something called flows. Now, well, we can't show you the flows here. Well, the flows is something like, it's more like the business workflow around a particular business process. So whenever there is a sale of this vehicle, perhaps there will be a workflow that there are certain number of steps that you have to take care of in a sequential manner. Then every business process is some kind of workflow, right? So those workflows could be modeled using the Corda flow APIs or the Corda flow framework. So that's the third component of your Corda, which will generally develop. So three things that will develop when you basically write a Corda app: the state, the contract, and finally the flow, right? So these are the component states, which are just your assets, which will be represented on your ledger. They get consumed, they get updated, and all these things. And then we have contracts, which will have certain rules. And each time you do a transaction, you have to run the contract, which is governing the state that, or the asset that you're trying to transact. And if all your contract validations are successful, only then we say that your transaction is valid. And finally, we have the flows, which execute your logic, your business workflow. You could see that there are certain steps that you follow, and all these steps will be taken care by your flows. So that would be something like um, validating your, so when I say the steps, you want to do a transaction, you have a step, which is one of those steps could be just validating your contract, right? That's a step. And where do you write that thing? That happens in the context of the flows. And then you have to share that transaction object with your counterparty, so that he could see the transaction and say whether this is the correct transaction, and he could also validate his contract at his end. So all these are different steps. We'll learn about that later on in more details when we do a proper sort of boot camp, and we'll also develop all these things. But yeah, for the for the intro part, you just need to understand that these are all these business workflows that you could model using the flow framework, right? Well, so we learned about all these, and how do what exactly is that your Corda node does, right? We just want to understand that. Well, Corda node is the real thing. Well, all your applications goes installed on your once you have developed your application, you have installed it onto your Corda node. You don't have to. Someone who's operating this node will not have to worry about all the low level things. Also, as a developer, you don't have to worry about that. You just have to call some inbuilt flows, and they will do all the stuff like something like storage, and then just pull out some other identity, anything like messaging your other counterpart. You don't have to do all the complex stuff around that, and neither the node or the node operator who is doing that will have to do that. All he has to do is know what all different transactions or different flows, we call them flows, are installed on your node, and he can just trigger them. You just need to know that this is a sort of I could say a command that I have to fire, and this will do this. And that would involve everything in the background, which will something like creating the transaction, sending it to your counterpart, getting signatures and all these things, key management and stuff. So all these are abstracted away. The node does the most of the heavy lifting for you guys. You don't have to worry about any of these low level things. You just need to write your application using all the APIs provided, and Corda node will take care of other things. So you run a flow, your Corda node will run all these low level stuff, and then it will update the ledger, right? So that's how the entire Corda framework works. Well, that brings us to almost the end of the session. So the next thing I would like to recommend you guys is we have CordaCon coming up, which is on the October 20 to 23rd. It's a 3-day virtual event. Obviously, we are not doing it in person this year, but you could join us for CordaCon. So feel free to register for CordaCon and have a and hear about some of the cool stuff that people are doing, and also um, some of the new things that would be coming up in Corda. All right. So that's it for today, and thank you very much for coming over here and trying to learn about Corda. I hope you had a great session. You got the very high level introduction to Corda, and that would help you to dig more into it. So feel free to join us in Slack. Look at the training if you want to learn more. Want sort of like a training environment, and tweet us. You want to join us, or you could, if you use LinkedIn, you could also find us in there. So all these links are over there. So yeah, thank you so much for joining, and I'll see you in the next one. Bye bye.